All right, so today we're going to talk about sound. So if you remember, sound is a compressional wave or a longitudinal wave, which means as the wave's energy is going from left to right here, the particles that make up the wave are going to travel back and forth, not up and down like a transverse wave. So I'm a huge Star Wars fan, all right, or a sci-fi fan. But the problem with sci-fi movies sometimes is if you look at someone screaming in space, all right, the vacuum of space where there's no matter. You know what it sounds like, right? It's going to sound like this. Okay, ready? Okay, it might be a little loud, so you might want to turn down your speakers a little bit. Ready? 1, 2, 3. That's it. That's what it sounds like in space. Why? Because sound requires a medium in order for it to travel, right? It can be either a solid, liquid, or gas, but it requires a medium. Now, there you go. The speed of sound depends upon the type of medium, all right? The denser the medium, the faster the sound. So like those old movies, like in your Western movies, okay, where the bank robber is going to come along and steal, you know, the bank's money off the railroad train, right? The old Western movies. Well, did they put their hand to the ear to listen for the train coming? No, what they did was they put their ear to the railroad track, and they heard felt the vibrations of that train way before they could hear it with their ears. Why? Because the railroad is a lot denser than the air, and particles will move faster. Well, why is that? So because we take a look at particles, you know, if my hands are particles, solid particles are close together, right? And so when sound travels through it, one atom bumps into another atom very quickly, whereas gas particles are farther apart. So it takes longer for that energy to take and transfer that information to another atom, and so forth and so on. Now, another thing that affects the speed of sound is temperature. The warmer the particles are, the faster the sound, which makes sense because when we talked about the kinetic theory of energy, all right, all the particles are moving, right? And as you heat up those particles, they start to move faster and faster and faster, right? So if they're moving faster, it would make sense that sound would travel faster if those particles are moving faster. Now, in order to hear, of course, we use our ears. And so the parts of the ear are going to be kind of broken up into 3 main parts, okay? You've got your outer ear, right? And that directs sound waves to your eardrum, right? That's the outer part here. That's the part we see. Then we have the middle ear, which we can't see with our eyes without, going into things. And then the middle ear is made up of 3 tiny bones. Now, these tiny bones are really, really small, and they're the same size from the time you are born to the time you turn into adult. They don't grow like your arms and so forth. Those 3 bones are known as the hammer, the anvil, and the stirrup. We'll talk more about those in a little bit in another diagram. And then we have the inner ear. Now the inner ear, this is known as the cochlea. All right. Now this is fluid filled. All right, and it creates the actual nerve pulses that travel to your brain that we start to make sense of and say, okay, this is what we're listening to. So let's take a look at a picture of the ear here. So we have the outer ear, okay? We've got the middle ear, right, which is made up of the tiny bones, and then we have the inner ear, which is the cochlea. Now, if we look at this diagram here, and it's a little small, the outer ear is made up of your cartilage, all right, and that kind of funnels the ear. Now, if you take and you cup your hand to it, you're just kind of extending it. So why do you do that? Because you're catching more and more of those sound waves and reflecting it into your eardrum. Now the tympanic membrane, or the eardrum here, this is a thin, very thin layer of tissue that vibrates, kind of like that of a drum, right? And as it vibrates, as it is struck by sound waves, that energy is traveled to or transferred to these 3 tiny bones. Now the tiny bones are the hammer, the anvil, and the stirrup. If you can kind of see it's kind of small here, but if you can see, the stirrup looks very similar to that of a stirrup for someone riding a horse. Now, if anyone's riding a horse, the stirrup is what your foot goes into. Now, here we have a picture of looking inside the ear, like when the doctor comes in, takes a look. Here we have a couple of things, some damages here. We've got a normal, healthy looking eardrum right here. Here we've got some that have some problems. Here we have a hole and some wax buildup, hardened wax buildup, stuff that's, causes problems with our hearing. So, when they say Q-tips are bad, Q-tips are really bad. So here we have an example of, the don'ts of ear care. We never want to take an ear Q-tip. It even says don't use it for your ears. Of course, everybody does. Because why? Because when you do that, you end up packing that wax against the eardrum. And then when it gets compacted, it makes it hard for you to hear. Excuse me. All right. So here we have an example of, some serious wax buildup. So that's it for sound, the basics. We'll talk more about sound and hearing loss later on in another video. If you'd like to take a look at some of the links to extra resources found within the slideshow, go down to the descriptor and click on that link found there.